All right, now I'm on the last tab here, and I think this is where it gets interesting. This is Florida Parcels valuation model, right? And so this is the kind of first taste of introducing inline, in many ways, no code modeling capabilities into our product. Not only from a SQL perspective, but being able to do this in Immerse as well. So we'll probably add additional UX for this over time to be able to kind of, just like you, I built the cohort earlier to be able to build these models and see the performance and the individual parameter coefficients interactively. But here I'm just using our custom parameter to add the model, and this is going inline in the SQL. Very simple. So this is I'm predicting sales price, the dependent variable. The independent variable is total living area, square footage, right? And this is a fit predict thing, right? So it's happening in place, which is useful for not everything, but particularly things like residual analysis, anomaly detection, houses that are under or over priced, fraudulent credit card activity, yeah, anything like this, right? Or things like null, if you have null values, being able to predict them in the data. So here we have this very simple model. See these two are from the underlying data, the average and median price. This is my mean absolute error, median absolute error, and median percentage absolute error. So on average, this very, very simple model is 25% off. Surprisingly good. Just square footage predicts a lot. And I can see other things about model error. I can see a histogram. It's pretty normally distributed. I can see it by county, etc. Okay, so that's great. Here on the map, we see that these are the pink areas. The errors are very geographically co-correlated. So negative 40%, these areas are performing way worse than the model would predict. Green areas, the houses are actually more expensive than the models would predict. But we can do a lot better, right? So naively, I might think that, okay, acres is going to help us here, right? So I added acres, barely moved the needle at all, right? Evidently not very correlated, and I think I have a filter here on acres. So I think we can do better than that, right? The next thing that we might want to try is I can actually do one-hot encoding, and there's syntax to be able to actually pick the exact parameters of it, but it will auto-pick the top 20, which gets us most of the way there for counties in Florida. So I did county name. Okay, so now I dropped from 25% to 19%. And you see a lot of the errors actually drop out. And so that's great, right? But I think that we can do better than that. So one of the cool things about SQL that's kind of hard to do in standard sklearn or something is that we can actually use SQL. I'm using window function syntax. And so I'm building a window, and you can actually do leads and lags if you order your window for like time series data. A little bit less relevant here, but I'm going to partition by county name. Okay, so that dropped my error to 16.8%. And so what it's effectively doing is it's building a model per county and inferencing on that. And so, okay, well, that's good, right? But maybe we can do a little better still. So I'm going to zoom into so we see our error dropping a little bit as we zoom in, but there's a lot more granular data in this data set, right? So instead of county name, let's try zip, which is just the zip code. Okay, so that dropped my error to 12%. So now we have a model per zip code, and I could even go deeper and do the census block. I think it's actually census block group. 8.61%. So just by the power of geo here, right, we're getting a much better kind of, much better residuals and lower error. And furthermore, I could refine and say, well, I really don't necessarily need a model predicting one size fits all. Okay, it's a little bit backwards here, but let's look at houses that are just under, say, roughly 800. Okay, and so it drops it to 7.9%. I can still find interesting anomalies in the data. For example, if I lasso here, right, I can see that the error is higher there. There's an area that performs better and an area that performs worse. And so we might actually want to dive into that, right? So this is kind of the power of interactive ML. I can see the different actually individual data. I can see, wow, there's still some anomalies, right? This predicted price was 477, but it actually only sold for 130. Why is that? This one, some of them, and I could even sort by, the residual or anything. This 522, right? It sold for 726 on 203, right? Why is that? So we could actually dive into this even more. But it kind of shows you the capabilities. You can also do clustering in product, and actually, let's see if I can try that here. Let's see, I'll do, so maybe I actually just want to see clusters in the product. So what I'll do is k-means total living area, maybe acres, and then we'll do why not actual year built too. Okay, and we'll look for, say, 4 clusters on 20 with 20 iterations. And oops, I have my scale locked still. Oh, there we go. Okay. So here we can see like different clusters of data. We can see kind of the beach houses. I could change the number of clusters if I wanted. And then we could actually do the analysis of each, and that might provide additional insight into why certain properties kind of don't fit the model well. So finally here, I'm just going to tease a little bit. We've been working on integrating deep learning into the product. First around object detection, but also more generally to be able to kind of do fit predict stuff like I was before, being able to import any generic. Here in this case, the initial focus has been on Torch, just due to the traction that this is getting. So this is actually looking at and I'll confess, I'm not running this live here, although it runs live just as fast. Just don't have it set up on this build here. But this is all doable as live inferencing. You can actually adjust the IOU estimates. You can adjust the confidence thresholds. Basically, we trained on our DGX and built a model on object data, XView object data. And it does, that was done on WorldView 3 satellite imagery. This is actually from the US GS. This is actually the data from aerial imagery orthographic surveys. And so totally different data set, roughly the same resolution. It performs admirably well, right? And so I can actually say, I want to look at all the small cars. It does do some mispredictions, right? Does it actually think all those are motorboats, right? And so the thing is that the model obviously was trained on different data. We could obviously do better on the model, but being able to generically pull this data in, and we ingested this raster natively, and to be able to get your model in and to be able to do real-time inference. Imagery is one place to start, but also potentially text data as well. We think it will be powerful for our customers, particularly as you can then join this data to other, like raster data in itself is not always that analytically valuable, but if you can take that and marry it to I want to actually count the quote-unquote cars in the parking lot, right? That's maybe the cliche use case by now, but there are so many different use cases where you can leverage this capability. And back to the heavy connect product capability, being able to in the near future pull in from the standard cloud geotiffs and the data stores, the geodata stores in the cloud, anytime, any place, and to be able to get augmented insights from it, we think will be a really powerful capability. So with that, this wraps my talk. I really appreciate everybody's time and attention. If you made it all the way through here, again, I think a lot of exciting things, a lot more on the horizon. This is just the start, but we really do see, that converged analytics on data science, leveraging the massive parallelism of modern hardware, particularly NVIDIA GPUs. It's going to be game changing for people, and it gives them capabilities that they never even thought were possible. So we'd love you to explore more. Come to our website, download Heavy AI free. Come talk to us in our community forum or reach out in any way. And excited to continue the journey together. Thank you.